So today we are going to a new section because right from the start of this subject up to yesterday's class, we were dealing either with DC circuits or with varying magnetic fields or varying electric current and thereby resulting in varying magnetic field. Now, in all those cases, I said there was a clash between Edison, who wanted DC to prevail, and between Edison and Tesla, who wanted AC to prevail. And because there was a it's in the history of mankind that there was a huge clash between these two concepts, whether DC or AC is required for our power distribution and all those things. Finally, I told you some of the history behind that, and finally it was Tesla who came up victorious, and he said AC is going to be the kind of nature of electricity that people will be going after, people will be using, mankind will benefit out of it. So today we are going to learn the fundamentals. Before Onam, I have just one more period, just the fundamentals about AC, alternating current. Now, what is the problem with DC? Why do you not use DC much? DC, direct current, is used for many applications, like charging of batteries, or be it for electroplating, or be it for electric traction, etc. But for large scale power distribution, nowadays AC is used, alternating current is used. Having said all these things, now the scenario is slowly changing because of the the advent of power electronic devices. Earlier it was not there. So semiconductor devices, power electronic devices. This is just for your information. Now the scenario is slowly changing, and most of the why do we need alternating current? What is alternating current, first of all? In an AC system, in an alternating current system, the polarity of the voltage, positive, negative, polarity of the voltage acting in the circuit changes at regular intervals, resulting in a corresponding change in the direction of current also, which means if you take 2 points in the AC circuit, at one second or one fraction of a second, one point will be positive, the voltage will be positive here, the polarity of the voltage will be negative here, the source, okay? And at at regular intervals, this changes. It becomes negative and positive, positive and negative, which means when the polarity changes, the current through the circuit, which is connected to this source, also changes its direction. At one time, it will be flowing from this to this. Another time, it will be flowing from this to this, which means in an alternating current system, the polarity of the voltage acting in the circuit changes at regular intervals, resulting in the change in the direction of current also. Now, what is the advantage here? Alternating currents, main advantage is that the alternating current, alternating voltage can be stepped up or stepped down. You may have to write the notes also, but on the note here on. The alternating voltages can be stepped up or stepped down. Voltage can be increased, voltage magnitude of the voltage can be increased or decreased as we require by using transformers. I just mentioned about the main phenomenon that is happening in the transformer, which is actually mutual inductance, electromagnetic mutual inductance. Mutual inductance can happen if and only if there is a varying magnetic field, or I can say only if the current through the primary, through the first winding number 1 is varying in nature. Maybe it's an AC current. If you pass AC current through the first winding, it means that there is a varying magnetic field produced, which gets linked with the second coil, and an EMF is induced in it. So only if you provide AC in the first coil or an alternating current in the first coil, a transformer can work. A transformer can never work in DC, because though there is a magnetic field, if you pass a DC current, though there is a magnetic field, the magnetic field is not varying. As per Faraday's laws of electromagnetic induction, in order that an electromagnetic induction or induced EMF is to be an EMF is to be induced in the second circuit by mutual inductance, this magnetic field linked with that circuit should vary. This can happen only in the case of alternating current, and so transformers can work only in alternating when an alternating current is passed through the primary, which means that we can step up or step down voltage by using transformers only in an AC circuit. Now, what is the need of stepping up and stepping down of voltages? Because for large scale power distribution, the voltage at which the power is to be distributed, power is to be transmitted from a generating station. Remember, our generating station, main generating station is in Idukki. Now, I am speaking from Trivandrum. So for me to get this voltage or this current or electricity in my home, the whatever is the energy or electrical energy is generated in the Idukki generating station has to be transmitted to some point and then distributed to me. Generation, transmission, and distribution. Now, what the voltage at which the generation occurs, or there are generators, and the generators produce or generate electrical energy at a certain voltage. Okay, as per the design of the alternator there or the generator there. Now, this has to be transmitted to some point, okay, from Idukki up to I'm staying in Kavdiyar. So, up to Kavdiyar, it has to be transmitted through substations, etc. Now, in the substation, you have transformers. Why are they keeping transformers in the substation? Because whatever energy, electrical energy has been generated in Idukki generating station has to be stepped up by a transformer kept in the Idukki, near the Idukki generating station, and then it is at high voltage that this energy or this electrical energy is transmitted, electrical power is transmitted through the transmission lines. So whenever you speak about transmission lines, about which in detail you will learn in the higher semesters, but whenever you speak about transmission, you are thinking about high voltage transmission, because if the energy is transferred at high voltage, the losses can be reduced. So usually transmission is done at very high voltages, the details of which you will learn later on in higher semesters. I am confining my discussion only to the level where you should understand why AC is required. Okay, so transmission. So in order to transmit the electrical energy at high voltages, I need a transformer or a substation just near the generating station, so that whatever energy is generated by the generator will be transmitted at high voltage. So you have a step up transformer there, and when it reaches the, if I'm speaking about my home, we reaches a substation which is situated near my home, it has to be, there are many substations in between also. Again, a substation there, a distribution substation where they'll have a transformer which will be used to, step down the voltage to the required value. So transmission is over. Now it has to be distributed to various homes, to my home. So what is the voltage at which I get it here? Even it was transmitted at 11 kV or so. 1 second, I have a phone. Ashwati, class forward ചെയ്യുന്ന വെച്ചേക്കൂ, കാരണം ഇതും കൂടെ കിട്ടിയിട്ട് വെക്കണം എന്നാണ് പറയുന്നത്. ശരി. Okay, so whatever high voltage at which it was transmitted, maybe 11 kV, I don't require 11 kV at my home. So it reaches the distribution substation, where again, every substation has a transformer. At the distribution substation, there is a transformer to step down the voltage, and it is stepped down at 440 volts or so, and then I get it, and then distribution is done. So my point here is that if I have to do all these things, to step up, transmit, to step down and distribute, I need transformers. And transformers, as I know by Faraday's laws of electromagnetic induction, works only if there are varying magnetic fields, or ineffectively I need AC current to be passed to the first through the primary. I hope that is clear. Now, why do I want it to be transmitted at high voltage? To reduce the power losses. Okay. The second thing is that because this was done, many of the great motors, see, all of you should understand our industry, which powers the economy, all the industries are the main, spinal cord, if I can say, spinal cord, or heart and soul of our economy, or whatever is produced, anything that you see around in our house, or anything that is useful for us, or anything, the train or anything that is manufactured in industries or factories, and almost 95% of all the industries have motors. And which motor? Induction motor, three-phase induction motors. So all these three-phase induction motors or single-phase induction motors that you see in your ceiling fan, everything works in AC because they are all designed as AC. So you cannot at a clap of a hand, you cannot change that whole thing into DC. They all work under the principle of AC. Third is that most of the switch gear, I hope all of you are writing this down. Switch gear means the protective devices, the switches, the circuit breakers. Suppose you have a fault occurring at some point in the power system, power lines, then you will be notified by KCB that there will not be current in your there will not be power in your house for say 9 a.m. to 5 p.m. or so. And are they switching off all the circuits or all the power system, the whole entire power system in Kerala? No, only in your location for some kind of maintenance or repair, whatever. So what they do is they use a circuit breaker, and all the many kinds of things are there. Let me not go into that. Those kinds of equipments are called as switch gear, GEAR, switch gear. Now these switch gears are simpler in AC circuits because when you learn the waveform of an AC circuit, you'll see that there are points where the AC value, current value becomes zero. Okay, so if you want to break a circuit, suppose I have current flowing through the circuit, and if I want the current to be, or if I want to break that circuit, if I want to switch off that circuit, I would like to do that when the current in the circuit is minimum. Suppose it's a DC that I'm speaking about, 200 amperes is flowing, or 20 amperes is flowing. If I suddenly switch off, if I suddenly open the switch, there'll be high sparking. But if I can make that the switching off, if I can time the switching off in such a way that it happens when the current is zero. So if I have a waveform, you will see later on, I know you all know that when you see a waveform, a current waveform in an AC, you'll see there are points where AC current becomes zero. And this switch gear can be opened. The switches can be opened at that point so as to reduce the sparking also. And hence their design is simpler. The switch gear is simpler in AC circuits. So, and now suppose now I am using a laptop, you are using many laptops or maybe mobile charging. All these things are done with DC, not AC. So how do you do that? What we do is whatever AC is available in our sockets, where whatever we get in our home, when we plug the mobile or when we plug in the laptop, etc., there is a rectifier also together with it. So that AC is rectified and the battery in the laptop or maybe mobile is getting charged, which means this was not the case when Tesla came up with AC. In that case, there was no need of DC at all, only for charging batteries or maybe for the applications which I say electroplating, etc. Now there is a widespread, I hope I'm not boring you, there is a widespread necessity of DC also because of the advent of TV, maybe everything. So you can see that all these equipments are having an inbuilt rectifier. Why? Because our power distribution system is AC in nature. So in order that these things have to be used, we require some rectifier which is inherently embedded in the device itself. That is how we are using most of the devices here. Okay. But now in this age where we are coming up with a lot of this kind of innovations, DC has also become very important. If we can do away with many of these inbuilt rectifiers, these most of these devices can become much more compact. So how is that possible? We have only AC in our power system. How can we do away with these rectifiers? We need DC distribution also. So people now, the very fertile research area in electrical engineering is, and also please remember this, the solar. We are very much focusing on renewable energy. The solar panel, all those things, these are converting what is essentially being done. The solar irradiation of sunlight is being converted into electrical energy. Okay, what is the nature of electrical energy? DC, which means Edison's concept of DC is now regaining its importance. We require DC as well because of the changed scenario nowadays. So one of the most fertile areas of research in electrical engineering is how to bring in DC also, direct current also, to your socket, to your walls. And this has been made easier because even though we don't have a transformer like this, we can have solid state transformers that are also coming up by using the power electronic devices. By using semiconductor devices, many things can be controlled. FACT devices, FACT devices, and such kinds of devices are coming up. This was not there in the times of Tesla or Edison. So these kinds of things have come in. These kinds of innovations are coming in. This is the area where we stand as of now. Okay. So though I told you all this, I told all these things because you're all electrical engineering students. You should understand that this is where we are now standing, or we are now at what is the state of art of the technology now. But now we are only concentrating on AC fundamentals. And as I told you, what is AC? A voltage which changes polarity at regular intervals of time. You have to note all these down. A voltage which changes polarity at regular intervals of time is called alternating voltage. When an alternating voltage is applied to a circuit, the current first flows in one direction and then in the opposite direction, which means the current or the direction of current at any instant depends upon the polarity of the voltage at that instant. Okay, which means what I wanted to, I am sure all of you know this, but then let me not skip also. So AC fundamentals. So if I have usually an AC source is denoted like this. Suppose I have a resistance like this. This is E. At one instant, I cannot say second, one instant, the polarity will be like this and the current through it will be flowing like this. All of you should understand that now I am using small I, small e, etc. to show that they are instantaneous values. Instantaneous values. Okay. Instantaneous values means changes from instant to instant. Oro second marikoli. Now, at one point, this is the case at one instant. At the second instant, what happens? This source E will have a change polarity, which means the current through the circuit will now flow in the opposite direction. Plus and another. So this is called AC voltage and AC current. It gets reversed and the direction of the current gets reversed. Polarity also gets reversed. Polarity of the voltage, direction of the current. Now, how can you represent this? One way of representing this is using a waveform. How do you draw the waveform? I have time t on the y-axis and instantaneous current or instantaneous voltage on the y-axis. So now I am going to draw a simple, some waveform. This is called as a triangular waveform. Triangular waveform. So this means current is going on increasing, reaches a peak value, and then it goes on decreasing, goes to the other direction, go on increasing and then decreasing, which means this is what I said about this. You have a point where the current or the voltage becomes zero. So switch gears can be operated easily, or the design of the switch gear is easily. And what do you mean by instantaneous values? Instantaneous value. The value of an alternating current. Please write this down. Instantaneous value. Value of an alternating quantity. The value of an alternating quantity in brackets, magnitude and sign. The value of an alternating quantity. I am just saying quantity because let it be a voltage, let it be a current or quantity. In brackets, magnitude and sign at any instant is called the instantaneous value. Is called its instantaneous value. So here I have I, E, etc. So instantaneous values are usually denoted by small letters. Now it's already 10:30. This is what I said. It's difficult for me to, Okay, I'll just stop. Let me reach some point where I can make a stop. Okay. One way of representing this is by using waveform. Another way of representing is using instantaneous values. But instantaneous value, which instant? So you use a equation. For example, E is equal to Em sine omega t. I is equal to Im sine omega t, etc. Or you use equations. So you can represent AC quantities by waveform, by equations, and many more things, or by its peak value. This is the peak value. We'll discuss this later on also. By its peak value, that is 3 is peak value, or by its 4, its average value, or very importantly, by its RMS value. We'll discuss why RMS value is very important, more important than the others which I mentioned later on in the class after Onam holidays. During the Onam holidays, I had given you an assignment. I hope you remember. Each batch consisting of 10 students. I had given you a homework which you have to do, and I make sure that you have a Google Meet and meet each other. So after the Onam holidays, we'll go deep into this. Otherwise, I don't want to hurry through this. I want to make sure that you understand. Okay.